Hello and thank you for watching this video. Please don't forget to like, share and comment on the video, as well as subscribe to Good Better Best online videos for more video content. Before we begin today's lesson, I'd like to dedicate this lesson to the grade 12s of 2024, especially my maths group. You guys have really been the stars of the show. So this is dedicated to Amber, to Caitlin, to Connor, to Ava, to Hannah, to Jason, to Jaden, to Kayla, to Logan, to Mbali, to Nicholas, to Seth, to Jordan, to Tanith, and to Tyler. I want you to remember something. There is nothing that you can't achieve if you set your mind to it. All the best for your exams. Hi there everyone. Today we are going to be looking over the November 2023 Paper 1 Calculus. So let's get started with 7.1. Our question says that we need to determine from first principles the derivative of fx is equal to negative 4x squared. Right, so what we need to do is we need to go ahead and substitute. We have fx is equal to f of x plus h minus f of x over h, right? What do? We substitute. We substitute for x squared, giving us minus 4 x plus h squared, and we subtract the original, which is negative 4x squared over h. And this gives us negative 4 times x squared plus 2xh plus h squared plus 4x squared over h. Don't forget, on the left hand side, we must always have our limit equal to 0. Our limit, as h tends to 0. Now, we simplify further and we have negative 4 x squared minus 8 xh minus 4h squared plus 4x squared over h. And we simplify. Negative 4x squared plus 4x squared will cancel, and we have negative xh minus 4h squared. We take h out as our common factor, and we are left with negative 8x minus 4h. Our h's will cancel. And once that cancels, we are left with negative 8x minus 4h. And as h tends to 0, which leaves you with negative 8x. Let's look at the next question. Now let's look at 7.2.1. We need to take the derivative of 2x cubed minus 3x. That's fairly straightforward. We take our 3 multiplied by 2. That gives us 6x. And then we subtract 1. So that gives us a squared. And then we do the same thing here. And that leaves us with negative 3. Let's look at 7.2.2. We've got to take the derivative of 7 times the cube root of x squared plus 2x to the power negative 5. So let's first look at what we need to do here. We've got 7 times the cube root of x squared. Now we know that x squared with a cube root becomes x to the power 2 over 3. And then we have 2x to the power negative 5. What we need to do now is we need to take the exponent and multiply it by the coefficient. So we have 2 over 3 times 7. And then what we need to do to the exponent is subtract 1. So we have 2 over 3 minus 1. And then we do the same thing here. Negative 5 times positive 2. That gives us negative 10. And then we need to subtract 1. That gives us x to the power negative 6. So that's 14 over 3 x to the power negative 1 over 3 minus 10 over x to the power 6. Okay? Why do we write it as 10 over x to the power 6? Well, if they want positive exponents, then we can write it like this. And then what we do with the 14 over 3, that remains the same, but we have x to the power negative 1 over 3. And if we want to write this as a positive exponent as well, we can say that it's 14 over 3 times the cube root of x. Let's look at 7.3. 7.3 says for which values of x will the tangent to fx is equal to minus 2x cubed plus 8x have a positive gradient. Okay, so when we see the word gradient, we know that we need to take a derivative. So that's what we do. We take a derivative of the first expression. So that gives us negative 6x squared plus 8. Positive means greater than 0, and so that's why we see the greater than sign here. And what we do is solve for x. So we are finding our critical values, and we find that our critical values, that's equal to negative square root 3 over 2 or square root 3 over 2. So what we do is we can plot that on a simple parabola. There's our negative square root 3 over 2. There's our positive square root 3 over 2. Where is this function negative? Okay, please don't forget the direction of the sign changes when we divide or multiply by a negative number. So we went from more than to less than. And where do you see less than in this function? We see less than in this white shaded area. So that means that x is greater than negative square root 3 over 2, but x is less than square root 3 over 2. Now let's look at 8.1. Here in question 8 we are given a cubic function, and what's nice about this cubic function is that they've already written it in that form, which helps us find our x-intercepts. Now let's look at 8.1 first. It says that we must determine the coordinates of the turning points of f. How do you determine the coordinates of the turning points? You need to take a derivative. So we take a derivative and we have negative 3x squared plus 12x minus 9. What do we do with that? We solve for x, and we see that x is equal to 3 or x is equal to 1. We need to take both of those values and we need to substitute for it. Where do we substitute in? Into the original equation. So we have f of 3, and that gives me 4. And I'm sorry about me writing over this here, but f of 1 is going to be equal to 0. Alright, so those are the coordinates of our turning points. Now they're asking us to sketch the graph. So our turning points are 3 and 4 and 1 and 0. To sketch the graphs, we normally need intercepts. We need, so our x and our y, we need our turning points, which we've already got, and our point of inflection. Right. For our x-intercepts, they've given it from this expression. This x minus 1 squared, this tells us that the graph will turn on that line. And then we have x is equal to 4. Our y-intercept is 4. Then our turning points, we calculated in 8.1, which is 3 and 4 and 1 and 2. And then our point of inflection, how do we find our point of inflection? By taking a second derivative. So we found our point of inflection, which is 2 and 2. So we take that second derivative, we make it equal to 0, solve for x, substitute into the original equation to find the corresponding y value. And we see that we get 2 and 2. And so there we have our graph. As mentioned, it will turn on the line, 1 and 0. There's our other turning point, there's our y-intercept, and this is our point of inflection. Let's have a look at the next question. It says, use the graph to determine the values of k for which negative x cubed plus 6x squared minus 9x plus 4 will be equal to k will have 3 real and unequal roots. Okay, so let's look at our current graph. Our current graph turns at 1 and 4. So we have a squared value here, but this means that as it is, the roots are real and unequal, right? So if we need to take into consideration where the roots will be real and unequal, it's going to be between the values of our turning points, which is 1, and that value there. Our second turning point is 3 and 4. So we're looking specifically at the y values. Here y is 0 and there y is 4. So k has to be greater than 0 but less than 4. If I were to shift this graph either up or down, then my roots will change, and that means it won't be real and unequal. Let's look at the next question. The line g of x is equal to ax plus b is the tangent to f at the point of inflection of f. Determine the equation of g. Okay, so here we need to find our point of inflection, which we did in, I think it was 8.2 already. We found our point of inflection, and we see that our point of inflection is 2 and 2. Now, what we need to do, we know that when we substitute our value of 2 into the first derivative, that will give us the gradient of our tangent. So we see that the gradient of our tangent is equal to 3, and this gives us y is equal to 3x plus c. What do we need to do? We need to sub a point on the line. And the point on the line that we are going to substitute, is the only point we have, is 2 and 2. That's for us to determine the equation of the line, and we see that c is equal to negative 4, therefore y is equal to 3x minus 4. The last thing we need to do in this question is we need to calculate the value of theta, which is the angle formed between g and the x-axis. I've drawn the tangent for you so that you can see the angle between the tangent and the x-axis is fairly straightforward because we've got the gradient. So all we need to do is tan our gradient, which is 3, and that gives us 71,57 degrees. Okay guys, so let's have a look at our last question. Our last question is our calculus application question. It says that show that the total area of the page is given by ax is equal to 3456 over x plus 6x plus 480. Right, so we know that the area of a rectangle is given by length times breadth, but what they've told us is that AD is equal to x. So in this case, when we work out the area of the shaded region, we can say 432 is equal to b times x. This means that b is equal to 432 over x. So now if we were to look at the area of the entire rectangle, we know that area is equal to length times breadth. And now we have to go about filling in that information. So we can see that our length is x plus 8 because we have 4 added on the left and we have 4 added on the right. And then our breadth is 432 over x plus 6 because we have 3 added on top and 3 added at the bottom. That's our length times breadth. And what we need to do is we need to simplify. So all we're going to do is simplify and multiply out, and we see that we get 3,456 over x plus 6x plus 480, which proved 9.1. Now let's look at 9.2. Determine the value of x such that the total area of the page is a minimum. Now whenever you see the word minimum or maximum, you need to remember that you need to take a derivative. So let's look at the expression that we had here, because this is the expression we are going to be using. It's 3,456 x to the power negative 1. Remember that denominator goes up now because we need it to be a numerator in order for us to take a derivative. Plus 6x plus 480, that doesn't change. And now we need to take a derivative. This gives us negative 3,456 x to the power negative 2 plus 6. The 480 is the constant and it will fall away. What do we do now? We need to take this expression and we are going to solve for x. So here we've multiplied out by x squared and we get negative 6x squared is equal to negative 3,456, and that gives us x is equal to plus minus 24, but distance is never negative, so what we can say is that x is equal to 24. So that's it for today, everybody. I hope you've enjoyed the session. I hope to see you guys again soon. Don't forget to share, like, subscribe, tell your friends about our channel, and leave a comment. I'd love to hear from you.